Hello everyone, welcome back. Today we will be solving one LeetCode question, container with most water. You are given an integer array height of the length n, and then find two lines that together with the x-axis form a container, such that the container contains the most water. Return the maximum amount of water that a container can store. Let's take a look at the example. Here we have the array height with the element 1, 8, 6, 2, 5, 4, 8, 3, 7, and each element in this array represents line with the height value. At index 0, we have the element with the height of 1, so this is 1, the vertical line 1, and at the index 1, we have the vertical line with the height of 8, so this is the vertical line with the height of 8. And we have to choose the two lines that can form a container that contains most water. We can see that the vertical line with the height of 8, this one, and the vertical line with the height of 7, this one, form a container that can contain most of the water. And the answer is 49. Let's take a deep dive into this example. This is the same example, and we know that the vertical line with the height of 8 and the height of 7 is the answer because it can form a container contain most water, which is 49. But where does 49 come from? So the output here is 49. First, we have to understand that the area can be calculated by using the width times height. So this is the area equal width times height. But how do we get the width and how do we get the height? The width is the distance between the two lines. In this array, the vertical line with the height of 8 is at index 1, and the vertical line with the height of 7 is at the index 8. So, width equal the second index minus the first index, which is 8 minus 1 equals 7. And what about the height? When we have two lines, imagine we have two lines like this. What is the real height that can contain the water? Of course, we will use the smaller height because anything that is higher than the smaller value here will spill out from the container. So the height will be equal to the mean of line 1 and line 2. In this array, 8 and 7, 7 is smaller than 8, so the height is 7. So our area will be equal to 7 times 7 equal to 49. Let me clean up our node a little bit. So our width will be equal to I, the index I, the first index, minus the second index. I will use I and j. And the height will be equal to the mean of the value. This is the array of the I element and the array of the j element, the first element and the second element. We use the minimum value between these two as the height. And the area will be the width times height. And this is our formula. Now, how do we tell the computer to know which line to choose? So first we can initialize I at the first index, at the index 0, and j at the last index, which is the index 8. And we have to loop from the I until the j because we want to explore all the lines in this array to see which line can contain most water. Here we will loop from I until j. Here should be j minus I because the second index minus the first index. And the second index is 8 minus the first index, which is 0, have 8. 8 is the width of these two lines, I and j. And for the height, 1 and 7, 1 is smaller, so the height is 1. So the area is going to be 8 times 1 is equal to 8. We also need another variable to store the final maximum area that we can get from this array. I will call the variable final max equal to max of the final max and the area. When we first start looping, we can just initialize the final max with the smallest value in our programming language. In JavaScript, we can just use negative infinity. Negative infinity and 8, which is bigger. 8 is bigger, so the final max for the first iteration will be 8. Now, how do we move I and j. We have two choices. We can either move I forward or move j backward. Here we will see which value is smaller. We want to move the line with the smaller value because we want to explore if there is any other element with the bigger height that can match with our current bigger height. 1 and 7. 1 is smaller. We move the I pointer here forward and we add the index 1. And in our formula, we will check here if the array I is smaller than array j. If it is, we move the I pointer. Else, if array j is smaller than array I, we move the array j backward. Because we want to keep the line with the bigger height and let the line with a smaller value to keep exploring to see is there any other element that have a better value, a better height that can match with the current height. Now I here is 1 and j is still 8. So 8 minus 1 is 7. For the height, 8 and 7, 7 is smaller than 8. So the height is 7. And the area will become 7 multiplied by 7 is 49. And the final max, 8 and 49, 49 is bigger than 8. So the answer is 49 for the second iteration. And then we move either I and j. And here, 8 and 7, 7 is smaller than 8. So we move j backward. And then the third iteration. Now, j is at the index 7. And I is at the index 1. 7 minus 1 equals 6. 3 is smaller than 8, so height is 3. And the area is 18 because 6 times 3. And the final mark is still 49 because 49 is still bigger than 18. 8 and 3, 3 is smaller, so we move j backward. J is at the index 6 and I is at the index 1. 6 minus 1 is 5. And the height is 8. And the area is 40. For the final mark is still 49 because 49 is bigger than 40. Now, when we have the situation that I and j have the same height, have the same value, it doesn't matter if we move I forward or move j backward. Here, we can just move j backward. Now, j here is at the index 5 and I is at the index 1. So 5 minus 1 equals 4. 8 and 4, 4 is smaller than 8. So here is 4. 4 times 4 is 16. And the final mark is still 49 because this is bigger than 16. Now, j is smaller than I, so we move j backward. J now is at the index 4. 4 minus 1 is 3. 5 and 8, 5 is smaller than 8, so here is 5. 5 times 3 is 15. And the final mark is still 49. And we move j backward again because j is smaller than I. J now is at the index 3. 3 minus 1 is 2. 2 and 8. 2 is smaller than 8. So here is 2. 2 times 2 is 4. And this is still 49. And we move j again to here. J now is at the index 2. 2 minus 1 is 1. 6 and 8. 6 is smaller than 8. So here is 6. 6 times 1 is 6. And the answer is still 49. And then we reach the end of our loop. So the final answer is 49. Let's code out the solution. I will initialize the final max equal to the smallest value, which is negative infinity. And the I pointer at the first index and the j pointer is at the last index in the array. And we have to loop from I until j. And our width is j minus I. And the height is the min of the first element and the min of the second element. And then the area is the width times height. And the final max is max between the current max and the area. And we also have to move the pointer. So here, if I is smaller than j, we move I forward, else we move j backward. And at the end of the loop, we return the final max. Let's check the result. What is the time complexity for our implementation? The time is O of n because we have to loop through the entire array, and the space is O of 1. Hope you guys enjoyed it. See you next time.